Okay, I'm live with Assimilating Onnx. And if you are not familiar with Onnx, it's a very interesting area of research in machine learning operations. And what I anticipate is that 2023 is going to be a year where many people are very excited about using models that are portable and embed inside of a binary. And that's what we're going to cover is really getting started with Onnx. What are some of the frameworks that are wrapping up Onnx? And let's see if we can make some progress. All right, I'm going to go ahead and get started here and share my screen. I'm going to go ahead and present here, and we'll go ahead and put this out there. That looks pretty good. And then what I can do is just make it a little bit bigger, and that looks great. Okay, so the idea here is that this repo is going to be the starting place for me to take a look at a few different things. Probably a good place to even begin is to take a look at what the spec is. And we see that Microsoft actually is the owner of this Onnx runtime repo here. And if we scroll down here, let's take a look at what it means. So Onnx is a cross-platform inference and training machine learning accelerator. It basically improves the performance, lowers costs, and can act as a conversion layer for multiple model formats. So this is, in my opinion, a really cool concept is that you can standardize on one inference runtime. And if it's going to constantly get better, we can actually get a very uniform experience here. And you can see here some of the different things that are available with Onnx, like we have Windows, Linux, Mac. There's Windows CPU. In terms of Linux, it looks like the current version of CPU is failed, but the GPU is succeeding. And we also have Open Vino, which, if I remember correctly, is for doing things on like physical devices. So like this thing, this Intel Movidius. But in general, this is a really cool concept, and there's a lot of fun things that we can do with it. If I go back to this repo here, that's one of the links that I have, but I'm also going to take a look at this Sonos, which I've only briefly played around with. And this is something that's been on my radar for a bit with wanting to package up models inside of a binary. And so we can see here this Sonos neural network inference engine is a toolkit that can read Onnx or in an EF, optimize it, and then run it. So what is kind of interesting about this framework is, do I need it? I don't know yet. A lot of this stuff is kind of bleeding edge. And then if we go back here, we also have the Onnx runtime in Rust. And this is, I think, maybe slightly more interesting for me. And this is an attempt at a Rust wrapper for Microsoft's Onnx runtime. So again, the idea here is that if you could package up the runtime in a Rust binary, that would be pretty amazing. And I think I see this being a critical skill for machine learning operations, right? Is portable binaries that do inference. I can't see why people wouldn't want this. And so I think this might be a good place to play around with first. So what I'm going to do is I'm going to go to this repo here, Assimilate Onnx, and I'm going to launch it in a code space so that I can actually start playing around with it. So I'm going to click on this, new with options, and then go ahead and configure a machine and then launch it. One of the reasons why I like doing these prototypes inside of code spaces is that it's a great way to build out stuff where I don't have to do a lot of the legwork of installing dependencies. A lot of the packages are pre-installed for me, and I don't have to actually do too much to actually get started here. And so this is based on a Rust-based template, so it shouldn't be horrible for me to actually get stuff started with Rust. So let's take a look at this and let's see here. So what do we need to do? They have a warning. they have an example. So it says to run this example. So it looks like probably what I should do is clone this repo. And I don't have a perfect way to do this yet because I don't want to push changes back. Instead, I just want to clone it. And so what I probably will do is just do this. I'll just clone as HTTPS. Let's go ahead and go here and we'll say, git clone. And then what I can do is just ignore, basically do a git ignore for this project. And that's one of the techniques that I do sometimes is, so I'll go ahead and do this and I'll go to the git ignore and say, look, we actually don't want this. We're this is going to be a exploring a runtime for Rust and Onnx. Ignore for now. Right. So then I'll just put in this. We'll ignore it. And then just to be safe, I don't know if I have to do this, but let's see here. If I say git status, what happens? Okay, well, it looks like that was good enough, right? So I don't have to do anything too tricky. Like I could still, I could essentially treat that as like a separate repo. And I'll go ahead and say git add and do git ignore. Say ignoring REST bindings. Onnx. Right. So next, what do we need to do here is take a look again at the tutorial, and it says example. The C++ example uses this. So to run this, we would basically go into, let's see, the C++ example uses C API, and the high level one uses Onnx runtime. So I think we want the next one. We don't want that one. We want to do Onnx runtime. So I'm gonna cd into that. Download the model. So we'll do this first. So we'll basically say download the model here, and I can even put some steps here, and I'll say day one. Okay, so trying the Rust bindings example for Onnx runtime RS. See if this works. So step one is I'm gonna cd into project. And step two, I'm gonna do this curl. So let's try that out. So let's cd into Onnx runtime, and then if I do this curl command, this is going to download the SqueezeNet Onnx model here. Well, that was ridiculously fast. Did that even work? Let's double check here. Onnx. I don't know how big this is. We'll say ls-lah. It looks like it's 203 kilobytes. It seems kind of small, but maybe that's what it was. And let's see what else we have to do. Oh, and then you just say cargo run example sample. So this is one of the cool things about cargo is it does make running examples pretty trivial. So let's go ahead and try this out. And so it's going to run, if we go inside of here, run example. It's interesting. How does it know when you do -s example? I see this sometimes with Rust. It must have, oh, I see. It must, or do I need to cd into that directory? That's the question. Probably need to cd into that directory. I bet you this won't work. Let's try. But who knows? Maybe it will. Yeah, I'm not sure how smart it is to know. How would it know to run sample if there is no example directory at the level I'm at? We're about to find out. I would be surprised if it works, but maybe it does. Well, it did appear to try to run it, but error calling Onnx C runtime. Protobuf party. So this might be too bleeding edge here. This repo may not actually be good to go. I am kind of curious though, how did that even work? I think I want to go to Onnx runtime and then run that command. It seems like it would, I guess it still worked either way, which is kind of interesting. But if we look inside of here, it says error file doesn't exist. Okay, well, at least we know how to fix that one. I can just go up a level and do SqueezeNet and put it right here. And if I run it again, here we go. Error calling Onnx runtime C function, protobuf. Well, so this might just be too bleeding edge here. That didn't work. Binding the Archimeded, this means to generate new bindings. So maybe I'm not following some kind of setup. Let me just follow the instructions here. So it says this is an attempt at the wrapper. We have this and this. The build script supports downloading. It's not working. It's completely working. Okay, well, but let's see here. There's 3 different ways to, oh, I see. Maybe I didn't install it. So download a pre-built, point to a local version, compile. So to select it, for example, so where's this build script here? Let's take a look at this. Build Onnx runtime. Let's take a look at that one. And we see source. The build RS script supports downloading basic inference works. Sample RS. Select which strategy to use. Until the build script allows compilation, see the compilation notes. To fix. See, I don't think I got that error message, or do I? Let's see what. Oh, yeah, I do get that error message. Oh, environment created. So it did create it, but I'm getting this. So let's see if I go to their repo and I look at the issues and I look at that protobuf. Nothing. Yeah, this may be too bleeding edge here. Fail. So I'm going to go to the next one, which is I'm going to try this one, which does look promising. And this may be a little bit smarter. So I'm going to do the same strategy. So I'm going to go to code. I'm going to click on this, and then I'm going to clone it into this repo. So let's go up to here. Go up to here. I'll just do git clone. And then again, I'm going to ignore this so that I don't have to worry about weird double git repos. There we go. So now if I say git status, yeah, we don't even worry about this. Ignore it. Add readme. Adding track. So this is where things get a little more tricky is with these bleeding edge tools. Doesn't mean we shouldn't do it, but so Onnx, it's, according to this, they're saying a lot of this stuff is working, which is more promising. We want to run a hello world here. So what do we got? We got some Raspberry Pi support, but where's your demo? I guess quick start. Let's look at, I think ResNet is kind of a cool demo. What do we need to do here? So it says adding PyTorch example. That's one. Then cargo run. See, I guess you would just Python export. Let's look at the export here. Export torch. Well, let's cd into this directory and let's see if let's start one by one. So I'm going to cd into the tract here. Let's go tract. So cd into tract, and we've got examples. And the one that looks interesting is the PyTorch ResNet. Now, one of the annoying things is that I tried to get away from Python, but I'm going to have to use a little bit of Python. And what I'm going to do is I'm going to say Python 3 dash m venv. Create a virtual environment. Of course, we've got all kinds of fun stuff, which means that if I want to make this reproducible, I'm going to need to put this into my build process, which kind of sucks. Let's go through here. Let's put this in. Right. So that means that if I run it again, I don't have to do this, which is one of the things you do want to do with code spaces. Okay, we got that. And I'm going to say get status here. Well, what I can do is do this. Get status up at the root. So this is just showing that I'm going to install virtual environment. And it's kind of annoying, but it is what it is. So if I go back here, we can just type in what I did before. Create a Python virtual environment, source it. And then if I want to be lazy, which I do, I'll just add this to my bash RC so that I, in theory, that I have to install Vim as well. There we go. Hopefully I don't have to edit bash much. So I don't think I'm going to add that to the build. But there we go. We go to the bottom. I just type in source. And so in theory, I don't have to worry about this anymore. And then I just say pip install whatever that script is that is inside of tract here. What was it? Examples. Well, I'm in PyTorch ResNet. It's going to be this thing. So what do we need? Torch division. Well, just create a requirements real quick. And then, oh, look, they already did it for me. Oh, great. So I'll just say pip install -r requirements. That's useful. Now, these instructions are a little bit cryptic, which seems like it's the way. Oh, great. Could not find a version that matches. Well, that's not going to help us. So we're going to have to just go bleeding edge here. This, again, is a little bit of a science experiment. I think it's the future. I think people do need to be working on this, but it's surprising how few people are working on the pre-trained models that are embedded in binaries. But hopefully this works out. Okay, we got this thing at least installed. And then if I go back to the README, well, actually, I go to the README up here. It says do Python export. Okay, we'll do that. So that'll be the first thing I do. Okay, so Python export. What happens? Well, it did something. It looks like it downloaded. If I do a tree, see that it did download this ResNet Onnx file. Okay, that's a good sign. That's a very good sign. Now, if this works, I'm going to be very happy. Let's see what happens. So now cargo run is basically going to build the whole project. So it's going to compile it. And in theory, if I understand the way that this framework works, is it packages the Onnx model inside and then allows me to have a binary that doesn't require anything else, which is really, really cool. Right. So this is I think not many people are doing this. And this is, in my opinion, one of the most cutting edge parts of MLOps is to be able to package the model in a binary. And I'm going to try it out. We'll try it out right now. Well, no errors so far. That's a good sign. I mean, the amount of packages inside of here is just staggering. Like, I mean, this is quite a project. But I guess this is the company that makes those speakers, which I actually have them. They're actually really cool. So it looks like they have some very cutting edge technology here. Okay. Getting to the end here. Hopefully it doesn't blow up. And if it does an inference, whoa, look at that. Wow, that's really cool. So here's the part that I think a lot of people don't understand about Rust and why it's so different than Python is check this out. So if we go here, notice that again, that what it's actually, if I look at the history here, we can find where it puts the we need to find where it put the binary. Hold on one second. Let me do it one more time. I'm going to do that. It's going to put the binary right there. So if I do that, see, that's my binary. So in theory, what would be cool is if I just took that and I maybe like did a CP into, I don't know, like temp or something. And then I go into temp just to prove, right? We should have this example, ResNet, PyTorch, yeah, this one. We should be able to just execute it. I don't know if there's something special you have to do. It was some kind of error, but at least the demo worked. So I need to now reverse engineer this a little bit. Sorry, wrong one. Look at this and see like, well, what is this doing? If we look at the source code, let's see if we can understand what's happening. So we first import tracked, and we load the model. Oh, I see. The model for the path is ResNet Onnx. I'm kind of curious though. If I'm going to copy that into temp. Let's see if we can reverse engineer how this thing works. So I'm going to, I have to go back to, let's go to this. Let's go to CD here. Let's go to examples. Let's go to PyTorch ResNet. If I CP ResNet Onnx to temp, and then in this other repo, cd into temp. Can I run this thing? Oh, it's doing something. Okay, so now it says no such file or directory, line 19. And if we go back to, if we go back to line 19, oh, it also wants the image. Okay, so that's really what I cared about is what do I need to include with this binary to package this up and deploy it somewhere. So I think this is it. So if I go back here and we look at this elephants.jpg here, let's also copy that to temp, and then we'll know what's the missing dependency. Does this work? There we go. So that is promising. So what that tells me is that it is able to, the binary works as long as those two files are included. Now, I'm not yet enough of a Rust expert here to actually know all of the ins and outs of how to put those put at least one of the files, like, because we really care about the Onnx to be inside of here. But I was able to get it working, which is pretty cool. So what would be nice is to convert this into a command line tool that accepted images, right? That would be, I think, the next step. And then the other one that would be a next step would be, why can't I include this embedded inside of the application? That would be really a kind of a cool example to figure out. And then the rest of the stuff should be pretty easy. So maybe I have to read up a little bit more on the documentation. So let's see here. So it says self-contained. Well, it said it's self-contained, but why do I have to copy that Onnx file? That's a great question. I guess I could just keep trying examples. So we have ResNet, but what about this one? What about Onnx Mobile Net? What does this do? So this project is a simple project showing how to process an image. So you CD into this one. So we would again copy it. So I'm going to CD into there. So I'm going to go back to this repo, up at a level, and it was not this one. It's going to be, let me move this over. So it's going to be Onnx MobileNet v2. So CD into Onnx MobileNet v2. Now the question is, will this one work? And so we will copy that. Models can, so we're not going to put it in there. And this is all kind of annoying, is that when you're working with these pre-trained models, it's like you have to keep downloading them and all that stuff, which, you know, is annoying. And now we have this Grace Hopper image, and then we just say cargo run should print a lot of things, but eventually, okay, so Grace Hopper is in here, I think, right? If I type in tree, yeah, so we have Grace Hopper. So go through here, cargo run. Let's try this one out. I guess it's going to be faster to compile because a lot of it, whoa, okay, so that did work. And so let's double check but it is the rank 654. So some rank 654. So if I said cat, is that included? I guess it is. So if I say cat and I say, oh yeah, you're right, it is 654. Military uniform. Okay. So again, the question is, we built this, but if I copy this to temp, what happens? Now, if I go to temp and we look inside of here and we say the example Onnx, what happens? See, it's got that same issue, but I guess I could copy the Grace Hopper image. So let's see, CP Grace Hopper to temp. This is really what I'm trying to figure out is how to make a model via a portable binary, right? This is the holy grail. Yeah, so it doesn't appear this is doing what I would hope it would do. So we look at the code. This looks good. But see, this model for path, this is the thing I really am curious about. It uses tracked as an entry point. I also use image. This line creates the Onnx. I mean, at least it works, but now the question is, and we interpret the results, but how do you package this? This is really the question. And so I have two examples working, but I think the real takeaway is how do I put it all together so I don't need anything? This may take a little bit of time to figure out. I don't see any more examples here without looking at their documentation. So let's look at it real quick. So a track introduction, a cookbook. So it's a neural blah 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 blah. It's a library that can load Onnx, which is cool. I'm glad they got that working. It supports this. Okay. Let's look at the issues here. Instructions. Yeah, what I don't see here is let's just put in the word binary or like distribute. Okay. Yeah, so I don't know yet. I mean, I guess the good news is I was able to get two examples replicated inside of this repo, but I'm gonna have to put some documentation here about next steps, and in a couple weeks I'll tackle it. So we'll say, the status of this was that got both ResNet and that one working by cloning repo. So let's even put notes here, research notes. And I copy both binaries to a temp directory. It needs both the model and the image in the same repo, which isn't necessarily that bad, actually. Now that I think about it, there's actually not that bad because at least the runtime works and it's portable, which is huge. And so we'll say the takeaway is runtime works, but need to have both model and image. So we'll say for day 2, or in a couple weeks, I'll tackle this, is we'll say need to solve model problem. So there's two ways I could solve it. I could say model portability problem. So problem 1 would be just, give user ability to download model. I mean, that actually would be pretty trivial via Rust CLI, and accept images via path, right? That would probably just solve the problem. B, which would be include model inside of Rust binary. But the bottom line is, I've not heard many people trying to work this out, but I think this is some of the coolest stuff that's happening in MLOps. So that's it. That's all I'm going to do for today. I'm going to check this in, go to workspace, and it'll be a couple weeks before I get back to this, but pretty fun. We'll add this README. So let's say working in progress on MLOps with Onnx. So hopefully some other people can try this out, and maybe you can beat me to it. Push. All right, see you in a couple weeks.